This is the second semester final review extra on Chapter 4, which was not part of the original videos, so I'm adding this extra section. Problem number 1, you invest $2,500 in an account with 0.8% interest compounded continuously. How much will you have in 12 years? Remember when you read these problems to be very cautious of how often the interest compounds. That's telling you what equation to use. So if it's compounded continuously, we're going to use this equation. So the amount in the account is the original amount, or the principal, e raised to the, now be careful when you change the percent. Remember, you change the percent by moving the decimal 2 places to the left, or dividing by 100. So it's 0.008 times 12. And when you plug this in your calculator, you find out you have $2,751, and it's $8.97, so we're going to round this to 90 cents. The second part of the problem says, how long until your investment doubles? Remember, when your investment doubles, you'll have $5,000. So when will the account equal 5,000? We're going to solve this one for t. Nothing else changes. We still use 0.008 for the rate. But we're going to solve this for t. So first you would divide by 2,500. Well, when you divide, you better get 2, because we said it was doubling. So 2 is equal to e to the 0.008t. To get that t out of the exponent, we're going to do the inverse operation of e to the other side. Well, you get rid of e by doing the natural logarithm. And then the last step of the problem would be to divide by 0.008. So we're going to do the natural log of 2 divided by 0.008, and that'll give us t. And when I plug it in the calculator, I'm going to find out it's going to take approximately 86.6 years to double my money at that interest rate. So just a reminder, if you're doing any other compounding other than continuous, you would use this equation, where n is how many times a year you're getting interest. So if you're getting interest annually, that's once a year. Semi-annually is twice a year. Monthly would be 12 times a year. Quarterly is 4 times a year. Weekly is 52 times a year. And daily would be 365 times a year. In order to solve a lot of log problems, it helps to be able to simplify multiple logs into a single logarithm. So we have these properties of logarithms that tell us how to do this. We have a property of logarithms that says if you're adding 2 logs with the same base, you can simplify them into a single log by multiplying these. If you're subtracting 2 logs with the same base, you can simplify into a single log by dividing. If you have a number being multiplied in front of a log, you can get rid of it by making that number the exponent right here. And last but not least, when we're solving log equations, if you have 2 logs with the same base equally to each other, then the logs end up canceling, and these are equal to each other. So we're going to use the properties of logarithms to help us simplify this. All right, so first of all, if you have a number in front of the log, it's going to go away first. It's going to become the exponent. So the first thing I'm going to do, I'm going to rewrite that as log base 5 of a to the 7th minus log base 5 m to the 2nd. Once you get rid of numbers being multiplied in front of the logs, now you can combine them into a single log. since it's subtraction, I'm going to combine it into a single log by dividing. So the log base 5 of a to the 7th over m to the 2nd. I can't do anything more with this problem. All I wanted to do was simplify it into a single log. For a lot of you, if you have a calculator with the newer operating system, under the math menu, you probably have a log base function that you can call up and just type this in order to solve it. It's a fill-in-the-blank problem. It pops up like this with these little dashed boxes, and you basically fill in the blanks. However, if you don't have that function on your calculator because you're working on an older operating system, that's okay. We can still do this using something called the base change formula. The base change formula is really what it says. It changes the base of the problem so that you can solve it in your calculator. The log base a of whatever can be changed into the log of whatever over the log of the base. In other words, you change the problem to be in terms of log base 10. Although it turns out that it doesn't matter what base we choose. If you want to use log base e, remember log base e is the same as the natural logarithm. This will result in the same answer. So for this problem here, I could do the log of 32 over the log of 3, or I can do the natural log of 32 divided by the natural log of 3. And I should get the same answer that I get if I have log base on my calculator. Either way, I should get 3.1546. In order to solve 10 to the 4x equals 8 for x, there's the quick, cheap, and easy way, and then there's the long way. And I can show you both. The quick, cheap, and easy way is to actually use your graphing calculator to help you. There's this nice little trick that if you forget how to solve an equation, what you can do is you can put the left-hand side of the equation into y1 equals, put the right-hand side into y2 equals, graph it, and then use the intersect function to find where they intersect. That's second trace 5, enter, enter, enter. I'll just say enter 3 times. And then you find out that the answer is 0.2258. The long way of doing it is to go and rewrite this in log form. In log form, remember the log base a of m, let's use it different, of x equals y, can be rewritten as a to the y equals x. And this definition is reversible. Sometimes we want to go from log to exponential form. Sometimes we want to go from exponential form to log form, which is what we're doing here. So I'm going to rewrite this as the log base 10 of 8 is equal to 4x. Now the nice thing about this is, remember base 10 is your common log. So all you have to do is type into your calculator log 8, and it's going to tell you that it's 0.9030899987 ... And then you can just divide by 4. And lo and behold, you will get the same answer that you got on the calculator, which is 0.2258. Now we're going to use the properties of simplifying logarithms to help us solve a logarithm equation. So in order to solve this problem, now by the way, I'm going to give you a little hint. Because you notice that the base is 10, if you forget how to solve something and the base is 10, you could plug this into your calculator. Now if you graph y2 equals 0, that's the x-axis. So what you're looking for is where your graph hits the x-axis. The algebraic way of doing the problem is to first get rid of any numbers that's in front of a log. So I'm going to rewrite this as log 5 to the third minus log 3 plus log x squared. I'm going to convert 5 to the third to 125. Now, I'm going to go from left to right to simplify this. So from left to right, first I have a subtraction problem. This is going to get rewritten as the log of 125 over 3. And now I have an addition problem. So that's going to get rewritten as the log of 125 over 3x squared. Now, I'm going to add the 2 to the other side. And I have to go back and rewrite this now in exponential form. Since the base is 10, it's going to be 10 squared is equal to 125 over 3x squared. 10 squared is 100. To get rid of that fraction, I'm going to multiply the other side by the reciprocal of 125 over 3, so it's going to be 3 over 125. So that's going to be 300 over 125 equals x squared. If you really feel the need to reduce this, you can, but you don't need to, because the next step of the problem is to square root. And I'm just going to shove that in my calculator. And the calculator is going to spit out about 1.55. But I'm going to put that ever-loving plus or minus sign in front of it. Because when you're taking a square root, you don't know if the number was positive or negative, because when you square it, you get a positive. Now, although you're not actually doing any graphing on the final, you may have to do some matching of graphs. So I want to tell you some stuff about exponential functions. The general function y equals a times b to the x has this shape if b is greater than 1. But if b is less than 1, it's going to have this shape. The only time the graph would be flipped over is if you were doing a negative. So if I did, let's go back to black. If I did y equals negative a times b to the x, that instead would look like this. So, and it depends on if b is greater than 1 or less than 1 as to whether it looks like that or that. But it gives you a general idea of what the graph should look like. What I expect you'll probably do is you'll probably just plug this in your calculator. When you do, you'll find out that the graph looks like this. Now, there are some other things you need to do, which is if there's multiple graphs with the same shape, then what I would do next is try to determine where the x or the y-intercept is. So when x equals 0, what's y? Well, it turns out that y in this case is 1/3. So you try to figure out which graph hits the y-axis at 1/3. You might have to zoom your calculator in order to find it, but you'll figure it out. And that is the remainder of the information that is on the second semester final but was not addressed in the previous videos.